Hello guys, welcome to this new session. In this video we will talk about and implement for loops, and the concept to do that called syntactic sugar. So it simply means that in our language we are capable to do loops, because in the previous session we did while loop. So the while loop, it's sufficient to do everything you want. Why we need to implement for loop is just a plus to our language, and it enhances the syntax, and also it enhanced the user experience and so on. So it's called syntactic sugar. The syntactic sugar mean just to simplify or to add something that you previously have, but you did it in another way. In this example, we've implemented while loop, but in this session we will implement for loop. So remember guys, while loop, you can do everything with while loop, and you can do everything with for loop, and vice versa. So we add that just to extend our language a little bit and add more sugars to it. So the syntax of for loop is something like that. The first part is for initialization. It could be a variable declaration or some assignment, and the second part is condition, and the final part is the increment. The condition help us to test if we need to loop again over the body, or we need to exit. And for increment, it's just an instruction that it will be executed after each end of loop, and then we will go back and test the condition. So after each end of body, we will execute increment and loop over to test the condition. So in this so as you see, the equivalent code of our for loop is something like: we start by opening a scope, and then we have an initialization, and we have while with condition, and also we have the body and the increment at the end of the loop. So the question is, why do we need to add the scope outside that while loop? So the simple reason, because we have the initialization. The initialization, usually it's a variable, so I need that variable to be just accessible only in the while loop. So when the interpreter interpret the rest of the code, that initialization, that variable, it will not be accessible. So I did that in that scope because here it will be declared, and if we end the scope, that initialization variable, it will not be accessible outside that scope. So for the bad code, we have 4 cases to treat, and for the case 1 is the standard one. We have initialization and condition and increment. So the bytecode will be the condition, and the other byte code is the jump if false, and also we have jump, and we have the section of increment, and we have loop, and we have body, and we have another operation code called loop, and the rest of code. So as you see, the VM will treat the condition, and it will read the jump if false, so it will see if the state of our stack is true, it will continue. If not, it will jump outside the loop. So if the state of our stack is true, it will continue to the jump, and in the jump we directly jump to the body, and we execute the body, and the VM continue, and it reach another loop, and it will loop over to the increment to execute the increment. Remember guys, the increment will be treated after the body is executed. The whole body is executed. So when the VM it updates its IP to the increment, it will execute the implement, and it will continue, and it will find some loop, and that loop, it will back over to the condition. So that's it for the case 1. So the case 2, when the user doesn't specify the condition. So what we need to do is just to remove condition with jump or false and update the jumping offsets. So we have jump, increment, loop, body, and loop and code. So we start from jump. We don't continue to execute increment because we have an instruction jump. The VM will execute directly the body and will execute the body until it finds some operation called loop, and it will loop over to the increment and it executes the increment and it finds another bytecode loop and it returns to the first instruction jump, and then it will jump to the body and so on. We have no condition, so the loop it will be executed over and over and over and over again. So the case 3, when the user doesn't specify an increment. So we have condition, object false, body, and loop and code. We don't have increment as here. So the VM will execute the condition. It will test if we have false or true. If we have false, we will exit the loop, and if we have true, we will continue to execute the body until the VM finds a loop and it will return to the condition and so on. So the last case is when we have no condition. We don't have no condition and no increment. So we have just the body and operation called loop bytecode and the rest of the code. So the VM will execute the body directly, and it has the next instruction loop, and it will loop over the body and so on to the infinity. So guys, let's jump to the code and implement for loops just to add more sugars to our language, to our syntax of our language. So let's jump. We will go to the compiler.c and we will update the grammar. So as you see in statement, we have while statement, and here I will add for statement. So let's add the definition for that non-terminal, and I will go here and I will do for statement, and for statement is defined by keyword for and open parent, and we could have variable declaration, var declaration, or expression statement, or directly a semicolon, and then we have expression, and it could be optional. Then we have another semicolon and expression, and it could be optional, and closing parent and statement to treat the body. Okay, statement. Okay, so the question that comes to your mind, why I did that? So variable declaration, its definition, it has a semicolon, and also expression statement, it has a semicolon. So I need to do 3 cases. If the user can specify variable declaration and it has semicolon, and that's good, and also it could be an expression with some semicolon, and also it could be directly a semicolon. So let's jump to implement that. Okay, everything is good. So let's go back to statement, and after while statement we will add another check. If it match the token for, what we call is for statement. And after the while statement I will add static void for statement. So guys, we will begin our scope. And also we will end the scope. So remember guys, we do an equivalent of for loop by doing the while loop. So the syntactic sugar is to add some sugar to our language and to use another syntax to implement the new syntax. So that's why I did begin scope and end scope, and then we will test. We will consume token left parent, and I will erase an error if it's not. Expect that after 4. That's it. So I will start for the initialization part, and I do if match token var. That means we have a variable declaration, and else if match directly I found token semicolon. So that means the user doesn't specify any initialization. So what I need to do is just to put some comment, no initialization, nothing to do. So else I will call the expression statement to treat that as an expression. So far so good. So what I need to do is to remember the loop star. So remember guys, in our cases we need to remember the loop star, where it starts, but for different cases the loop star is changed. So in that case we have the loop star is the condition, for that case the loop star is the jump, and for that case we have condition, and for that case we have the loop star is the body. So at the first time I need to remember the loop star because I don't know which case we are in. So what I need to do is that to read the count of our chunk count, and I will specify some help for variable. Let's remember -1 because I will use it when we have a case that we don't have jump if false or not. So in that case, especially in that case, because in that case we don't have that jump if false. Okay, and also for that case. So I need somehow to control when I need to emit that byte or not. So let's go back and let's continue. I will do a test. If it doesn't match token semicolon, that means that the condition part is specified by the user of the language. Okay, I will call expression on the condition part, and I will consume token semicolon, and I will raise an error if not, expect semicolon, and I will emit jump up jump if false, because we have the condition part. Remember, in the condition part, in this case we have a condition, so we need to emit object, and also in that case we have condition, we need to emit object if false. The other condition we don't have condition, the other cases we don't have conditions, so we don't need to emit that byte, and also for the condition 4. So let's jump, and also as usual I will emit byte op just to free the stack from the value of the condition. So that's it. Okay, I remember the jump offset, so because after that I need to specify where to backpatch that, so I need to remember the offset. So when we finally emit that loop, I need to backpatch after that. I need to backpatch that to see where the VM should put the IP. So let's go back and let's jump to if doesn't match token write parent. That means the user is specify the increment part. So I will remember the jump body. I will emit jump up jump. So we have jump. So this jump, its function is to jump to the body. So I need to remember its offset. So that's why I did that. So we are in the increment part. What I need to do is to remember the increment star, where it starts. Why I need to remember that? So remember, we have increment. So the increment, I need to remember its position, because when I will emit the loop, I know that I need to loop over to the condition. So I need to remember the position of the offset, because I will emit the loop, so the count is the offset of that. So that's it. So I will, on the increment part, I will call the expression to reach that increment part, and I will consume token write parent. So I will say expect after 4 clauses. So I will emit byte up, and I will emit the loop on the loop star. So I will emit the loop on what? On the loop star. Loop star in that case is this condition. So in that condition the loop star is jump, so I will emit the loop to point to that. And also, so that's it. Okay, so after that I will update the loop star to be the increment star, and I will jump back. Okay, it's called backpatching the jump body. So the question is, why do we update the loop star to be the increment star? So I need to remember, because as you see in that bytecode, we have the loop, and that loop is pointing to the increment. So for in the perspective of that loop, so the loop star is on increment, so I need to update that, because after that, after treating the body, I will emit that loop on that one. So in the perspective of that loop, the loop star is increment, and for this loop, the loop star is the condition. As you see, it's just a matter of which loop we are talking about and the perspective of which loop. If we are talking about this loop, so the loop star is increment, so I need to update that. So let's jump to the body. So the body it will be treated by statement, and what I need to do is to emit loop on the loop star. So we treat the body. So I need to emit the loop, but that loop on which instruction will be pointing to. So for this case, it will loop on increment. So the loop start of it is increment. For this case, the loop is on increment also. For this case, the loop is on condition. So for this case, the loop is on body. So if we are in the condition that increment is exists, so the emit loop will loop over the increment. So let's see the conditions that we have. We have increment. So as you see, in that case we have increment. So that loop, it will be emitted to the point to the increment. For that case, we have also increment. It will be pointing to increment. For these two cases, the loop, it points to condition or body. So let's see. So let's talk about that condition if we don't have the increment. So if we don't have the increment, the loop start, it will be on condition, or it will be on the body. So if the condition is specified, it will loop. It will okay, here. So if only the condition is specified, the loop, it will be pointing to condition. So the final case, we don't have either the condition or increment, it will point to the body. So that's it. So what I need to do right now is to check if exit jump is different than -1, which means that the condition part exists. The condition part exists, so it's the time to backpatching the exit jump. And I will emit byte up. So this means that the condition exists and the value of exit jump exists. So if we don't have any condition, we don't need to backpatch or emit the up jump if false. So let's turn to the whiteboard and see that. So we don't have conditions, so we don't have up jump false. We don't have conditions, so we don't have up jump false. So we don't need to backpatch that. So we have accomplished the for statement. So let's do an example to see if that it's working. So let's go to and let's recompile the project. So as you see here, we have compiler.c. So we can write parent. So let's clean and let's make all. So everything is good. So let's create a sample example, and we will do same thing but with for loop. So we have var x equal 1 and x is less or equal than 10, so x will be x plus 1, and let's print x. So let's see what will happen. So let's see the bytecode. So in our case, we have the condition and the increment at the same time. So here we have a simple printing. Here a local variable. Remember that it's not a global variable, it's just a local variable, as you see here, because we did a begin scope and end scope. And here we have a condition and test the condition. Okay, so also we have jump to 31 if false, and 31 we have pop, and we have also pop. We have a jump to jump over the increment, so 29. So here is the 29. So the increment is here. We will get the local variable, we will load the constant one, and we'll do addition and set that, and we will do pop, and then we will loop over to get to the condition. From 26 to 5 we will start the condition from the beginning. So that's good. And here when we print, we need to loop over to instruction 18. As you see, we have 18. Where is 18? So here is 18. We jump to the increment. So when the body is executed, we need to jump to the increment. So the increment is on the 18. So we get the local, we load one, we do addition, we set that and pop that. So that's it's the increment. So that's good. So let's see the state of the stack on runtime. So as you see here, we load 10 local, and we load 1, and we do addition. So we have here we are in the increment. We set that, and after that we loop to the 5 to test the condition. We get local constant, and we do the comparison. So we have false, and then if we have false, we jump to the 35, and 35 will pop, and we do another pop because we did end of scope, and we halt the machine. So let's go to common.h and deactivate that to see. So let's recompile the project. Equal. So let's do something like, let's cut the example and let's run our interpreter on it. So as you see, from 1 to 10, 1, 2, 3, 4, and so on. So let's go to next case. In the next case, we will not specify any increment, and the increment I will do it inside the loop, so to avoid the loop will loop over and over again. So let's activate debuggings, and let's make clean and make all. So let's clear that. Also let's see the bytecode. So we don't have the increment. So the case that we don't have the increment, where is that case? So in that case, we only have object false and loop only. So as you see, we have object false and only loop. So far so good, and as you see, we have the intended result 6, 7, 8, 9, and 10, and we exit the loop from here. So good. So let's check the other state. So in that one, if we don't specify the loop and don't specify the increment, that loop it will loop over and over and over again, and that's not good. So you will see a bunch of bytecodes that pop-ups on the screen, and let's see. So let's cut the sample and let's sample it end, and as you see we have a lot of looping over. As you see, we have a lot of things because we don't have a condition to stop the loop. So see you guys in another session. In this session we did something really good. We extend our language to add some sugar to it. It's for statement. We can do everything with while, and we can also do everything with for, but we add that for loop. It's just to extend our language. We add some sugar, we add some taste to it, and it's enjoying and helpful for user to write whatever the thing that it feel better on it, and it feel better to code with it. So that's it guys, see you in another session.